Let us talk about light in wave optics part 1. Last time we had learned the electromagnetic waves. Now we see the wave-particle duality. These are the photons. We know that light sometimes behaves like particles and it sometimes behaves like waves. Let us see the particle theory explained by Newton in Newton's corpuscular theory of light. Every source of light emits large number of tiny particles known as corpuscles in a medium surrounding the source. These corpuscles are perfectly elastic, rigid and weightless. These corpuscles on emission from the source of light travel in straight line with high velocity. These particles enter the eyes. They produce image of the object or sensation of vision. Corpuscles of different colors have different sizes. When light corpuscles strike a reflecting surface, they undergo elastic collisions and as a result follow the laws of reflection. During refraction, it is the difference in the attractive forces between the corpuscles and the particles of the medium that cause the change in the direction of the corpuscles. A denser medium exerts a large attractive force on corpuscles to accelerate them along the normal to the boundary. Velocity of light in the denser medium was thought to be greater than the velocity in rarer medium, which was not correct. The drawbacks of the corpuscular theory were: the speed of light should be greater in a denser medium than in a rarer medium. This prediction was contrary to the experimental results. The phenomenon of interference, diffraction and polarization cannot be explained at all. The particles are emitted from the source, then mass of source must decrease. Experiments show no change in mass. It could not explain partial reflection, refraction at the surface of a transparent medium. Now let us see the electromagnetic theory. That's by Maxwell. Velocity of electromagnetic wave was found equal to the velocity of light. Hence, light waves were assumed to be electromagnetic waves. No medium is required for propagation. Electromagnetic waves can have the wavelengths ranging from very small, smaller than a femtometer, 10⁻⁻15 meters, to very large, larger than a kilometer. Now let us see Maxwell's electromagnetic theory. Velocity of electromagnetic waves was found to equal to velocity of light. Hence, light waves were assumed to be electromagnetic waves. No medium is required for propagation. So, Max Planck's quantum theory states that light is propagated in the form of packets of light energy called quanta. Each quantum of light is called photon. Each photon has energy E is equal to h into nu. Nu is the frequency of light, h is Planck's constant. Now let us see the wave theory of light. Light travels in the form of longitudinal waves of uniform velocity in homogeneous medium. Different colored lights are due to different wavelengths of waves. When light enters eyes, you get the sensation of light. A material medium is required for propagation of longitudinal wave called ether. The success of this theory, the wave theory, it could explain laws of reflection, refraction, interference, diffraction, etc. Speed of light in optically denser medium is less than that in optically rarer medium. The drawbacks of this wave theory is it could not explain rectilinear propagation of light, polarization of light, phenomena like Crompton effect and photoelectric effect. The experiments by Michelson and Moll concluded that there was no ether drag when Earth moves through it. This and other experiments prove that ether does not exist. Next time, we are going to learn more about the wave fronts and the rays. Thank you. To be continued.